Okay, today we're going to talk about power functions, and it says a power function is a function of the form f of x equals a times x to the b power, where a and b are real non-zero numbers. So to the left, this little box to the left, there's some examples of some power functions, and notice that we have a squared, a negative second power, a 1.5 power, and a 2/3 power functions. So it first says, write each of the following as power functions, then state the values of a and b in the power function. So let's start with this first one. We have 7.4 times the cube root of x squared. We're going to write it as 7.4. Let me see if I can get this one here. 7. Oh, it's not going to write like that. Okay. So we'll do 7.4. And then that's going to have an x times x to the, and we're going to put a power on it. And remember that your root is your denominator. So this would be to the 2/3 power. Okay, so then your a value is obviously 7.4. And your b value is 2/3. Okay, let's look at number 2. So the function is 9 divided by x. Well, obviously, we're going to start off with 9 as our a value. We're going to write x with a power on it. Then you have to remember, how do we take a variable in the denominator and put it in the numerator? Well, that's where that little negative comes in handy. So this would be x to the negative 1 power, where a is 9 and b is negative 1. Okay? Alright, check out number 3. F of x equals the square root of 64x. So remember how you can break it apart. This is the square root of 64 times the square root of x. Then the square root of 64 is 8. Okay? Then we have the square root of x. Well, that's going to be times x. Square root of x is going to be to the 1/2 power. Remember that 2, that denominator 2, comes from this understood square root right here. So then a equals 8 and b equals 1/2. Okay? All right, look at number 4. You're going to have to simplify first. So look at your numbers, your coefficients. All right, you get 6 divided by 4. Okay, that would be 3/2, which is 1.5. Okay, now we know we're going to have x next to it. And we need an exponent on the x. So notice that we're dividing like bases. So we subtract exponents. So we have 1 minus 5 would give us a negative 4. Okay, and obviously a is 1.5, b is negative 4. Okay, so let's apply this to a word problem. The period p of a pendulum, or the length required to make one complete swing, varies directly as the square root of the pendulum's length x. So let's do this. Let's do period. All right, and then we have varies, and it is varying directly, and it varies directly as the square root of the length. Square root of length. Okay, now the period is denoted with the letter P, right? Varies directly is equals, and that's going to be K times length is X, so this is going to be the square root of X. Okay, So now we're going to put it into A. A pendulum 25 centimeters in length has a period of 0.5 centimeters. So our period is 0.5. That's going to equal K times the square root of the length, which is 25. Uh-oh. Okay, I'm learning these tools. So let's see, I've got this. Gonna put the pencil back on. So we got the square root of x. Oh, there's that thin one. Okay, so we're trying to solve for k. So we're going to, oh, our x is 25, isn't it? Let me erase that. Got this line in there. Just messed everything up. All right, put the pencil back on. And this is going to be the square root of 25. All right, so to get k by itself, we're going to divide both sides by the square root of 25, which is 5. All right, 0.5 divided by 5 is 0.1 equals k. All right, so find the constant of proportionality k. We did that, and we're going to use it to write an equation to relate the pendulum's period and the length. So we have period P equals, in place of k, we're going to put 0.1. And then it's going to be the square root of x. Okay? Now, B says to write the period of the pendulum as a power function of its length p of x. So this is the point of doing this. All right, so we have p in terms of x, p of x is going to equal 0.1. And now we're going to write x with a power that's going to give us the square root of x back. So that's obviously going to be x to the 1/2 power. Is that what you were thinking? Good. And remember, this denominator of 2 is the understood 2 on the square root right here. And the 1 comes from x to the first power. So C says that the pendulum's length is increased to 100 centimeters. What will be its period? So we're looking for period, we're looking for P. So we have P of x. Actually, x is going to be 100. P of 100. Right? P of 100 is going to equal 0.1. Oops. 0.1 times the square root of 100. All right, then that will equal, well, square root of 100 is 10. 0.1 times 10 is 1. All right, and since we're finding period, period is denoted in a unit of seconds, so this would be 1 second. Okay, the period will be 1 second. Now, number 6, underneath this, go ahead and try number 6, and I will do number 6 in a separate video following this one. Okay?